Oh, hello there. You want to know about confidence intervals? Well, let me explain to you. A confidence interval is one of two types of estimation procedures. It allows us to calculate an interval of a variable that the population value would fall in. The confidence interval percentage represents the confidence of the researcher that the population value falls within a certain range. An example of a confidence interval being used as an estimation procedure would be when you want to know the average IQ of a community of randomly selected sample of 200 students. So the formula for calculating confidence interval is the x bar is the mean, the z value from your alpha level, and then this is the standard deviation of the mean. So for our sample, we have a mean of 105 IQ. 1.96 is the z value. The standard deviation will be 15, and the sample size is 200. This means the confidence interval is 105, and it ranges from 102.92 to 107.08. Another way to write this would be 102.92 mean If we need to know the confidence interval of a sampler proportion as opposed to a sample mean, we use the formula. In this case, the PS is the sample proportion and the PU is the population proportion. So in our example, 42% of a random sample of 764 people in a city are liberals, and we want to know what percentage of the entire city are liberals. So first you would change the 42% to a proportion as 0.42 plus or minus the z value. The PU will always be 0.5. Over the total sample of 764. We can just round this value to 0.07. So this means that 42% of the population plus or minus 7%. So this means 35% or 42%, 49%. So 35 to 49% of the population falls within the category of being liberals. Now, there are some limitations to confidence intervals. The first one is that when you actually calculate the range, there's still a margin of error in every value. So for example, for these values, we have a confidence interval of 95%. That means that there's still a 5% chance that the value falls out of the calculated range, though the probability is still very low. Another limitation of the confidence interval method is that it doesn't give specific values. What I mean by this is that the point method, which is the other estimation method, will give us an exact percent for the sample population. The confidence interval, on the other hand, will only give us a calculated range and not the exact value. So in this example, we have 35 to 49. Point estimate method we're used instead. It would be an exact percentage like 42 or 43.
The research question we will be using for our estimation procedure is, what is the average income of professors at McMaster University? We choose to measure a data set of the income of professors at McMaster University. We found a record of McMaster University employees' 2013 salaries and benefits. These employees include any type of professor, director, or dean. Data set collected was in alphabetical order and recorded by the university. We selected a sample using random probability sampling. We took every fifth salary and recorded them into the SPSS database. The sample consisted of 187 data pieces out of a population of 542 professors total. In order to answer this research question, we will be using SPSS for Mac to produce confidence intervals sample of the 2013 McMaster faculty employee salaries. The first thing we will be doing is using the explore command to compute the confidence interval for the mean total salary. First, we will select the option Analyze, then Descriptive Statistics, then Explore, a dialog box should appear, and when it does, you will move the desired variable to the dependent list box. We will be using the 95% default confidence level. However, if you wish to change this, you would do so by selecting Explore Statistics and typing in your desired confidence level. However, keeping with the default confidence level will mean just clicking OK. The descriptive output table contains a variety of statistics used to measure central tendency and dispersion. We will focus on the confidence intervals for the sample mean, the lower bound values, and the higher bound values of the 95% confidence interval for the mean. The lower limit of our interval estimate is 141,168.88, and the upper limit is 153,430.19. Another way to state this interval would be 141,168.88, which is less than 147,299.52, and which is less than 153,430.19. We estimate the professors at McMaster University on average have a total income between 141,168.88 and 153,430.19. Because alpha value was set at 0.05, this estimate has a 5% chance of being wrong, in other words, not containing the population mean for total income. We should point out that values in our output may contain numbers with the letter E, sometimes expressed as lower e. This stands for exponent, or the number of tens you multiply a number by. SPSS will use the exponent to represent a number with too many digits to show in the output. If the exponent is shown in your output and you would like to view the regular value, we will right-click any part of the table in the output window. Then click Edit Content. Then you can select the SPSS chart editor window titled SPSS Pivot Table Descriptive. This window is there to give options for the final appearance of the table. Now you can use your mouse to increase the width of the statistics column by dragging the table line that separates the statistic and standard deviation error columns to the right until the exponent changes to regular form. When you are finished editing, you will close the SPSS Pivot Table Descriptive window to return to the output window where you can see the changes. Here we will produce an error bar graph for the confidence interval for the mean of the total income. We will click Graphs, Legacy Dialogs, and then Error Bar. An error bar dialog box will appear, and we will click the simple option that is highlighted. At the bottom of the error bars dialog box, we will click the Summaries of Separate Variable radio button within the data. Then click Define. The Define Sample Error Bar dialog bar appears with variable names listed on the left. We will use the cursor to find the variable in the list on the left and then right-click the right arrow bar to transfer the variable to the error bars box. In the Bars Represent box, we have the option to select whether the error bar represents the confidence interval of the mean, the standard error of the mean, or the standard deviation. We will choose the confidence interval for the mean, the option that is already selected. We will enter the desired confidence level into the level box. We'll use the 95% level, which is the default setting. We will click OK, and the following bar graph will be produced. The error bar graph will provide us with an example of the exact illustration of the information given in the descriptives output in the demonstration about constructing confidence intervals for sample means. The mean income of the sample respondents is about 147,299.54, marked by the small circle on the bar. The mean income of all the McMaster professors is somewhere between 141,168.88, the small horizontal line at the bottom of the bar, and 153,430.19, which is the small horizontal line at the top of the bar.
Therefore, according to our confidence interval calculation, we are 95% sure that the average income of professors at McMaster University ranges from $141,168.88 to $153,430.19. This error bar graph gives us a visual representation of this. The lower bar represents the lower range cutoff of 41,168.88, and the top horizontal bar represents the upper limit of $153,430.19, and the dot in the middle represents the mean salary of $147,299.54.